All right, guys, so in light of trying to help get through these ideas and trying to help understand how to put these ideas together, I'm going to go ahead and talk through this. If you don't need to see the whole explanation, then go ahead and skip to the end and get the answer. But I want to make sure that you're understanding the principles here and the ideas that we're trying to use in order to answer questions like this where we're adding together complex vectors. All right, so here in the beginning, I've got vector A. Right, vector A is at 45 degrees. It's got a length of 4. Okay, I'm going to go ahead and draw it out. Okay, it goes in that direction, and that's vector A. Vector B then adds on head to tail, 150 degrees, goes back the other direction, and I may or may not know exactly how far back this needs to go, but it is supposed to be longer than the 4, so I'm going to make it a little bit longer there, going back that way. And this right here is your 150 degrees. All right, now I'm going to try to avoid doing any really difficult, challenging trigonometry here, as I'm sure that many of you will be thankful for. But this is my vector C, right? That's the result. I start here, I go to the end of A, then I go to the end of B, and that's where I end. So my vector C starts at the bottom here and ends up there. Now, the process for finding vector C. Okay, the first thing you're going to do, and I'm going to break this down into steps because I know a lot of people find that helpful, is to find the components of the vectors you are adding. Okay, now in this case, I'm only adding the A and B vector. Okay, but this method, and the reason we learn this method is because it will work if you have 5 or 6 vectors. Remember, we did this in your homework last night. You added 8 individual components together, and it gave you the same thing no matter how you added it together, right? And so if we break it into components, we know that we can add it together in any order and still get the correct resultant vector. So the first thing we're going to do is find the components of the vectors that we're adding together. Okay, now to do that, don't look at this. This is going to be too confusing. All right, so we're going to go over here to the side. We're going to do vector A first. All right, so vector A is right here. It's got a length of 4. It's got an angle of 45. Now, a lot of you are having a hard time figuring out, where's my right triangle? How do I draw? Well, that's because you were looking at this guy over here on the left. Don't look at that. Look at this guy right here. See? It's easy for me to draw a vertical piece and a horizontal piece. Okay? Now, the horizontal piece is going to be the x component of A, and the vertical piece is going to be the y component of A. And so here, I'm going to need to use my trig. So, ka, toa, right? And so I'm going to use that to find, first I'm going to go AX. Now AX is adjacent to 45, and I have the hypotenuse. So I'm going to use the adjacent and the hypotenuse. There we go, that's cosine. So I'm going to go cosine of 45 equals the adjacent, which is a to the x, over 4. Now the nice thing is that means that I can just multiply both sides by 4 to get the answer. So I'm going to do the cosine of 45, and then I'm going to multiply that number by 4. And the answer is 2.82. And I'm going to write down 4 digits here. So AX equals 2.828. I'm writing down 4 digits because I know in the end I'm going to round to 3. So I'm going to keep a little bit more. If you can keep more digits than that, great. But I'm trying to keep it simple here so I don't fill up the screen too quickly. All right. Secondly, we're now going to do AY. Okay, now that's the opposite side and the adjacent, the hypotenuse. So opposite hypotenuse, that's going to be sine here. Okay, so I'm going to go sine of 45 equals the opposite, AY, over the hypotenuse, which, again, I can multiply both sides by 4. 4 times sine of 45 is going to give me AY, which is 2.828. Now, the nice thing here is that I can see that my horizontal vector went to the right. That was positive. It gave me a positive answer. And then my vertical vector there, the AY, went up. Sorry, that was supposed to be yellow there. Went up. And so that was also positive 2.828. All right, so now I've done vector A. I'm going to do exactly the same thing now with vector B. This is still finding the components of the vectors I'm adding. I found the components of A. Now I'm going to find the components of B. So B, if this is my horizontal, B goes back in this direction, right? So that's 150 degrees right there. Okay? Now, with that 150 degrees, it's going to be really hard to make a right triangle. And I saw some really good ideas. I saw some people drawing right triangles up this way and some other things. I'm going to do it down here just because I like to always do it with respect to the x-axis. That simplifies some things later on. Okay, now if I'm doing that, I really would like this angle right here. B was 6 units. Okay, so if this is 150 over here on the right-hand side right here, then this has to be 180 minus that, which is going to be 30. Okay, so that's 30 degrees. And so again, I want BX and I want BY. So in similar fashion, in order to do that, to get the X, that's the adjacent side. This is why I like to do it with respect to the x-axis, because it's still going to be the adjacent. And the hypotenuse, right, is again going to be adjacent hypotenuse. That's cosine. So again, I'm going to have cosine of 30 equals the adjacent over the hypotenuse. Okay, and then I'm going to do the same thing for by, the opposite over the hypotenuse. So sine of 30 equals by over 6, the opposite over the hypotenuse. Okay, you'll notice that should give me by, which is the vertical piece, and it should give me bx, which is the horizontal piece. Okay, now I'm going to go ahead and work these out. Okay, so I'm going to go 30, and then I'm going to go cosine, and then multiply that by 6. And I'm going to get 5.196. So this is bx equals 5.196. And then I'm going to do by, which should give me 3. I'm going to put 0.000 just so that it has the same accuracy as the other ones. All right. That would be 6 times sine of 30. Okay. And so now I've got all of I've finished step 1. And I know in talking through it, that took a long time. But all you're doing is finding the components. Okay. That's just trig, right? You don't have to see it all as the same question. See it as one question where you're going to find the components of A, and then a second question where you're going to find the components of B, just like this, and break it up into pieces, break it up into components. All right. Now, step 2 is to add the horizontal pieces together and add the vertical pieces together. Okay, this is kind of like the lab that you did, right? In the lab that you did, you're going to you added horizontal and vertical pieces all together, but it doesn't matter what order you do it in. You can put all the horizontal pieces together first and get an overall horizontal component. And you can add all the vertical pieces together and get an overall vertical piece, right? That's really what we're doing here, right? And so I showed you guys a table earlier where I was trying to organize it, right? Where I had my x values and my y value here. And so I took vector A, and I took the x value of vector A, which was this guy right here. The x value was 2.828. Okay, so 2.828 is going to go here. And then the y value was also 2.828. Okay, one thing that I didn't mention as I was working, I should have mentioned this as I was working through vector b over here, is that when I solve for vector bx, notice that it's going to the left. Okay, because it's going to the left, that number needs to be a negative number. So this is actually going to be negative 5.196. Okay, the by is going up, so that's still positive. But anytime a horizontal vector goes to the left or a vertical vector goes down, the values are negative. This is just like any coordinate plane, right? When you have x and y, if your x value is negative, it goes to the left. If your y value is negative, it goes down. Okay, so this is very, very consistent with the mathematics that you already know. But you do have to be careful to include that there. All right, so I've got my a there, and now I'm going to put vector b down. The reason, again, is so that I can add these together. So vector b is going to be negative 5.196, and the y value is going to be 3.000. And now I'm going to actually put those together so I can get vector c. Okay, I'm going to put the two horizontal pieces together, these guys. Okay, I'm going to add the two horizontal pieces together. I'm going to go 2.828. And then I'm going to add on the negative 5.196. And I get negative 2.368. Okay? And I'm going to do the same thing with my y values here. I'm going to add together the y values. So I'm going to have 5.828. Now, this should kind of make sense, right? If you look back at the original graph, you have your vertical A right here and your vertical B right here, right? Those two things added together should give you the same thing as this vertical C over here, right? Those should add up to give us the same thing, right? And again, I'm comparing this, the vertical part of C, to adding the two vertical pieces of the two vectors that I've put together. All right? The same thing is true for the x, right? If I take this horizontal of x, which takes me over here to this point, and then the horizontal of y, which goes back in the other direction, it overlaps. A couple of people mentioned the overlapping things when you did your lab. Yeah, that's okay, it overlaps. And that should give you the same thing as this horizontal piece for C. All right, that's the whole point to what we're doing here. We're trying to get the horizontal piece and the vertical piece component of that final C resultant vector. And that's exactly what we've done here, is we found the x and the y. Okay, so first, break the vectors into components. Then add together the horizontal pieces and add together the vertical pieces. If I had more vectors here, I'd just list them all here. I'd do it all at once. I can add in all the horizontal pieces, 3, 4, 5, 27 horizontal pieces, add them all together, and then all the vertical pieces, add them all together and get a final number. Okay, this saves me from having to do trig on every single little thing that's being added on. I just break each one up into pieces and find the components. Okay, now at this point, I have that the x component of C. Now what I'm going to do is I'm going to take this triangle and I'm going to redraw it right over here. Okay, so I've got Cx, which is negative 2.368. That's what I just got. That's the horizontal piece of C. Okay, I have the vertical piece of C, which is 5.828. Those should come together to give me this vector C. All right, now to get that, you do Pythagorean Theorem, right? Do Pythagorean Theorem to get a squared plus b squared equals c squared. This is a right triangle. It's a horizontal and a vertical. That's the whole point, is by working with horizontal and vertical components is really going to make this a lot easier in how we get these answers. All right, so go ahead and do Pythagorean Theorem. We're going to go 5.828 squared plus negative 2.368 squared equals c squared. And if you solve that, punch that into your calculator, hopefully you get a value of 6.29. Now, of course, that's not the final answer because c is a vector, and a vector has magnitude and direction. So I need a direction as well. So I'm going to try to find that using my trig, right? So I can find this angle right here using tangent, right? I have the adjacent and I have the opposite. Yeah, I also have the hypotenuse too. You could use sine or tangent, sine or cosine if you want. I'm going to go ahead and use tangent. I'm going to go tangent of this angle is equal to the opposite, 5.828, divided by negative 2.368. Though in this triangle, the length of that is 2.368. So I'm not actually going to put a negative there, okay? Because with the triangle, I'm not worrying about. The only reason why there's a negative there is because that's the direction, right? And the direction isn't going to be important for this angle right here. So I go 5.828 and 2.368, and I find the inverse tangent of that, 67.9. Oops, I lost my marker there. Theta equals 67.9. And so the final answer will be 6.29 at, and I know you really want to say at 67.9, but that's not quite right, because remember the angle always has to be with respect to 0 here. So it's going to be 180 minus that 67.9. All right? And so we should be able to get our final answer, which is 112 degrees, or 112.1. Though I'm going to put 112 because I'm going for 3 sig figs here. And so this right here will be our final answer. And that's it. So notice we did step number 1, find the components of the vector you're using. Adding number 2, find the horizontal, add the horizontal piece together, add the vertical piece together. And then step 3, use the resultant x and resultant y to find the final resultant vector. And that's it. Those are our 3 steps. Now each of those steps, yes, has some mathematics in it, okay? But if you can get through that first part of breaking into components, the other pieces aren't so bad. Putting things together, getting the angle, it won't be as bad if you can get it into components, all right? So that's the end. I hope that's helpful. I hope that you're able to use that as you work through some vector questions later. All right, that's it.